Good morning. Welcome to Viticulture 2020. My name is Giz Gaskin. I'm fruit expert at Yara UK. Today, I would like to look at the importance of calcium in viticulture with you. Calcium in viticulture, when we think about calcium, we think about three main factors that it influences. Growth and vigor of the plant, that impacts on disease tolerance, and it also impacts on skin strength. Growth and vigor. The calcium pump within plants is a very simple process. As the plants uptake their nutrients, M, P, and K, in the spring, in order to develop new leaf, new growth as buds open. Calcium is also uptaken as it's a requirement of the lignin and the structural cells needed as they develop and unfurl. Once we approach fruiting, plants tend to translocate the key nutrients back out of the foliage towards the fruit in order to develop the fruit further. Calcium, however, is an immovable nutrient, while at the same time, because it's already been utilized in structural cells and lignin, it's unable to be translocated into the fruit. This means that it remains within the foliage and within the branch stem matter. In order for the fruit to develop, the plant required to uptake new calcium in order to develop that fruit and that new growth. So the plant continues to uptake the calcium from the soil or from foliar-fed sources. Once moved up into the fruit, then the calcium can be used to support both the skin strength and the epidural layer. Calcium in grape doesn't really exist within the juice of the grape. It lives primarily within the skin or the epidural layer. So the juice that's produced from the grape rarely contains high quantities of calcium if calcium has been used in bulk for the benefit of the crop. Looking at disease tolerance, and I say tolerance because calcium can't cure botrytis, but what we're thinking about here is we're thinking about strengthening the crop and the berries so that the botrytis can't latch onto that crop and then infect it. If we look at the graph on the left, you can see three lines. This is a year-by-year incidence of controlling sprays to see if there could be an impact from calcium to botrytis. In the first year, the control year, there is no calcium applied. And what you see is that the botrytis tends to take effect on the crop about 9 days after variation. At the point it takes hold of the crop, it then consistently develops through the season till end of harvest, whereby it's reached a level of approximately 85%, which is quite high when you think about it. Following years, calcium was sprayed post-variation. What we see is that the crop has managed to stave off botrytis for 21 days after variation. But once it's on the crop, we notice that the rate at which it infects the crop is very similar to the control, such that by the time it reaches harvest, it's infected the crop to the tune of just under 60%. When we look at calcium which has been applied from the beginning of the crop, pre-variation, we notice that the berries are much more resilient to the impact of botrytis, staving off impact till 31 days after variation. But interestingly, the steepness of the incline is more reduced versus the control and even the post-variation spray. So the rate of impact of the botrytis on the crop is affected by the quantity of calcium within the crop, reaching a level of about 20% in this case. Calcium really helps the strengthening of the skin, and it's also that in turn has a resilient effect to attack from fungal pathogens. We see that both in the leaf and in the fruit. However, as discussed already, calcium cannot be translocated through the plant, which means that the plant really requires a constant and steady supply of calcium in order to develop both vegetatively and fruiting. Drosophila, or Suzuki fly. This is not so much of a problem in grapes. Drosophila is a very big problem in soft fruit in UK. It's come in from the Far East, and the real issue from Drosophila in UK is that the UK doesn't have as strong a winter as you would want in order to wipe out Drosophila between years. So what we tend to see is continuing generations cycling over as they run through a mild winter, hiding in the vegetative growth around the fields and other weeds, and then coming out and causing a lot of problems within UK soft fruit. As you say, in winter it's quite mild and medium level, but come summer, when UK fruit is at peak, you have very high pressure of Drosophila with a built-up pressure in the autumn, which is an issue for viticulture because the majority of your fruit is coming in the autumn when the pressure of Drosophila is very high. Now, Drosophila is attracted to fruit which is entering maturity. So ordinarily in grapes, this is not an issue, but if you have varieties which have a weaker skin or are prone to splitting, then Drosophila is a very opportunistic pest and will be attracted to those grapes in particular. We notice in the male that they have two spots at the top of the wings, which makes them very easy to spot in the field. But the female doesn't have these spots, but does look slightly similar to the male, although they're usually a little bit larger than the male. The female has on her abdomen a spike which sticks out down at the bottom and has a slightly serrated edge to it. This spike is used by the female to cut into the fruit. And if we consider that the female is actually only 3 millimeters in length, the length of the spike is approximately 0.5 millimeter. And if you consider then the strength of the skin of the grapes, I would say most grapes have quite a good, strong skin. And the female would be unable to actually penetrate that skin with this spike. But then varieties, as I said, which are more advanced in their maturity and have a thinner skin or have begun to split, the female is very much able to take advantage of those grapes and penetrate the skin to lay her young, or to take advantage of the splitting and just lay it straight into the fruit. The issue really here between the pest and disease on grapes is more that it affects the quality of the must that you're going to use for wine production, as opposed to an out-and-out visual look of grape. If you look to the left, you can see a photo which demonstrates the impact of Drosophila on grapes. These berries, which appear raisin-like, are where the young has entered the fruit and has already begun to feed on the internal flesh of the fruit. But what we notice here is very signature. If you notice these spots and drops on the outer surface of the fruit, this is where the female has punctured the fruit. The fruit has continued to develop as it pushes through maturity, but the juice that's being entered into the grape in order to bulk it up is being forced out of the hole that the female has already created. And that leads to this sheen that tends to be visible on the outside of the grapes. The secondary aspect of this is that having a sticky juice on the outside of the grapes then makes them a prime site for your fungal pathogens to take hold of these grapes. So we see that the control of Drosophila is actually very difficult, but what we aim to achieve by using calcium properly with the grape is to reduce the site in which the female can attack the grape, while at the same time strengthening the skin so that should she attack, the skin is strong enough to repel. Some work here that was done with Sauvignon Blanc in New Zealand demonstrates that, let me move that forward, demonstrates that splitting can greatly be reduced by the application of foliar calcium. As much as 40% it can be reduced. So when we think about Drosophila, we're certainly working on the idea that we're trying to prevent the Drosophila from having an impact on the grape. But once the female has laid eggs within the grape, it is very difficult to then be able to control those youngs. So it's very much a prevention rather than a cure approach. If you're curious as to how much Drosophila is present in the field, and from some of the other suppliers, perhaps you can find a monitoring pot which contains a lure to attract the female. Usually some other companies will allow you an opportunity to count up how many females are present in the field, so that you can have an idea pre-maturity of what sort of pressure is possible in your crop. Application of calcium. Yara has been working with calcium for a long time. Within the root zone, we have two products that are available. The calcinate is more a soft fruit product, although it can be used for viticulture. The product is really lending itself in its formulation to tea-line irrigation and fertigation, as compared to Tropicote, which is a prill product. This is more of a broadacre product for farms which are not using fertigation yet. Stop It, by contrast, is our foliar-fed calcium. There's been quite a lot of success with Stop It. It's used in cherries and apples for the prevention of bitter pit, while at the same time it's used to increase the skin strength of cherry. And there's been quite a lot of good research done in Stop It's use in viticulture, demonstrating that it can increase the skin strength of grapes. Thank you very much for listening.